Good morning. Today we discuss about galvanic cell. Cells are two types. One is electrolytic cell. Second one is galvanic cell. Electrolytic cell and galvanic cell. Electrolytic cell. The cell which converts electrical energy into chemical energy is called electrolytic cell. Electrolytic cell and galvanic cell. These electrolytic cells require only one electrolyte. What is electrolyte? The process of decomposition of substance by process of electricity through it is called electrolyte. These electrolytes, by using electrodes, by process of electricity through the substance, the ions move opposite electrode side. Process is called electrolytic cell. In this cell, positive ions and negative ions are moved opposite electrode side. The cations move to cathode side and anions move to anode side. At the anode, by loss of electrons to liberate as a gas, at the cathode, those electrons move from anode to cathode. At the cathode, already present positive ions. Those ions gain of electrons to form a substance at deposit at the electrode. Now we discuss about galvanic cell or voltaic cell. The cell which converts chemical energy into electrical energy by spontaneous redox reactions is called voltaic cell. The cell which converts which energy? Chemical energy into electrical energy by spontaneous redox reactions is called galvanic cell. In galvanic cell, electrons flow spontaneously from the negative electrode, that is anode, to the positive electrode of cathode. In this cell, two electrodes, one is anode and the other one is cathode. In this cell, the electrons move from anode to cathode. Electrons move from anode to cathode. Compounds of two separated half cells. The compounds are arranged in two half cells, which each consists of a metal rod or strip immersed in a solution of its own ions and inert electrolyte. These galvanic cells are made up two different electrolytic solutions. In these two different electrolytic solutions arranges two electrodes. Those electrodes are its own ions or releases electrolytes are taken to different containers. The compounds of two separated half cells, which each consists of a metal rod of strip immersed in a solution of its own ions or an inert electrolyte. The electrodes are connected by wire. These electrodes are connected by wire, and the circuit between the two half cells is completed by salt bridge. These can be any medium through which ions can be slowly processed. The electrodes are connected by wire. These electrodes are connected by wire, and the circuits between the two cells is completed by salt bridge. This can be any medium through which ions can slowly passes. Two different electrolytic solutions. These two different electrolytic solutions arrange different electrodes. These electrodes are connected with wire. Two half cells are contact with salt bridge. U shape of tube completely fulfill salt components of mixture like potassium chloride, ammonium chloride, potassium sulfate immersed in U shape of tube. These U shape of tube contact two different electrolytic solutions. This bridge is called salt bridge. The electrons flow from the anode to cathode through an electrical current rather than passing directly from substance of electrolyte. Arrangement of galvanic cell. In this cell, galvanic cell or voltaic cell, electrochemical cell that converts the chemical energy of spontaneous redox reaction into electrical energy is called galvanic cell or voltaic cell. A device which converts chemical energy into electrical energy by spontaneous oxidation reduction reaction is called galvanic cell. These cell taken two different electrolytes, zinc sulfate solution and copper sulfate solution. Zinc anode immersed in zinc sulfate is act as anodic of cell. Zinc sulfate solution arranges zinc plate. The zinc plate act as anode. This anode indicated by positive charge. Anode indicated by negative charge. Copper sulfate solution. Copper cathode immersed in copper sulfate solution. It is act as cathode. This cathodic of cell. Zinc sulfate solution and copper sulfate solution. Zinc sulfate solution, zinc plate act as anode, so this half cell is called anodic half cell. Copper sulfate solution, immersed copper plate act as cathode, this half cell is called cathodic half cell. Anodic half cell and cathodic half cell, these two half cells connect with salt bridge. These two half cells are connected by inverted U-shaped tube is called salt bridge. It contains potassium chloride and potassium nitrate or potassium chloride and ammonium nitrate. This salt bridge mixture of salt components fulfilled in U-shape of tube. These U-shaped tube connect to different electrolytic solution. The salt bridge prevent mixing of two solutions. It does not mixing two different electrolytic solution. It avoid mixing of solutions. The salt bridge to prevent accumulation of charges. No electron transfer from one electrolytic solution to another electrolytic solution. Two different electrolytic solution, electrical contact between two half cells. Electrical contact between those two half cells have same anions of sulfates. Those sulfate ions concentration will be changes by loss of electrons from anode to cathode. Such ions transfer from one solution to the other solution by the balancing of ionic components. These ions transfer from one solution to the another solution by the balancing of anions in two different electrolytic components. In this figure, we see zinc sulfate solution, copper sulfate solution. The zinc plate and copper plate connect with voltmeter. These two different electrolytic solutions contact with salt bridge. One is anodic half cell, another one is cathodic half cell. Anodic and cathodic half cells. Working process of galvanic cell or functioning of galvanic cell. How it is work? Zinc anode immersed in zinc sulfate solution is act as anodic half cell. Zinc plate act as anode. This anode loss of electrons in valence cell. Those electrons move from anode to cathode. This anode is indicated negative charge. Those negative charged anode loss of electrons at zinc plate. The zinc undergoing oxidation by loss of electrons. Zinc gives rise Zn plus 2 plus 2 electrons. Electrons are produced at zinc by loss of Zn plus 2 interface. This electrodes is called the anode. Base oxidation occurs. Zinc plate act as anode. This anode, when it is contact with cathode of copper, then immediately loss in its valence cell of electrons, then form Zn plus 2 plus 2 electrons. Then zinc plate act as anode. Anode is represented by negative charge in galvanic cell. Those electrons move from anode to cathode. In zinc plate of the cell is called anodic half cell. anodic half cell. In this half cell generally represented Zn to Zn plus 2. Zn to Zn plus 2. Zn to Zn plus 2. What is the reaction? Zn gives Zn plus 2 plus 2 electrons. At anodic half cell, loss of electrons at anodic of zinc plate. The zinc plate acts as anode. Those electrons transfer from anode to cathode. At the cathode already present copper plate. This copper plate acts as cathode. Those electrons gain from zinc plate to copper. This copper arranged in copper sulfate solution. This cell is called cathodic half cell, which is electrons comes from zinc plate. Those electrons gain copper plate. It undergoes to reduction. This cathodic half cell undergoes to reduction process. Electrons are pushed through the conductive wire and through the work device, a negative motor, a light bulb, or a voltmeter. These cathodic and anodic half cells by transfer of electrons then produce electricity by the reading of voltmeter. At the cathodic half cell, the electrons at the cathode collide with copper plus 2 ions attracted to this locus of negative charge and reduce them to metallic copper. At cathodic half cell, by gain of electrons from zinc plate, then this Cu plus 2 gain of 2 electrons to form copper deposited at Cu. Electrons at the cathode collide with Cu plus 2 ions attracted to this locus of negative charge and reduce them to metallic copper. The electrons at the cathode collide with Cu plus 2 ions attracted to this locus of negative charge and reduce them to metallic copper. At Cu plus 2, gain of 2 electrons to form Cu. This reaction is called reduction reaction. How it is work? Ion migration, the salt bridge. The anodic half cell and cathodic half cells, these two different half cells by the transfer of electrons from anode to cathode. These two half cells contact with U shape of tube mixed with salt components are completely arranged in tube is called salt bridge. The salt bridge contact these two half cells. It is prevent mixing of solutions. It is prevent accumulation of charge. It is made electrical contact between two half cells. How it is electrical contact between two of cells? Sulfate ions. Those ions migrates through the salt bridge and Zn plus 2 in the other direction to keep charges balanced. By the transfer of sulfate ions from salt bridge, when zinc plus ions increases at anodic of cells, those anodic of cells transfer of electrons from cathodic of cells. These cathodic of cells already present copper ions. Those ions form copper by the reduction reaction. This copper deposited at copper plate. Then sulfate ions transfer from cathodic of cell to anodic of cell to keep charges balanced. That is one of the cell reaction completed. Galvanic cell. Cathodic of cell reaction. Cathode. What is a cathode? In this cell, the following reactions are involving in galvanic of cell. At cathode of cell. Cathode. CuSO4 solution acts as electrolyte. In this electrolyte arranged as a copper plate, this copper plate acts as cathode. This cathode gain of electrons from anode. This copper plate gain of 2 electrons from anode to form copper. This reaction is called reduction reaction. At cathode, by gain of electrons from anode to form a metal. These metal are deposited at cathode. Then these cathodic of cell completed by gain of electrons from anode. This reaction is called reduction reaction. In this reduction reaction are completely filled by at right hand side and anodic of cell. Zinc sulfate solution act as electrolyte. In this electrolytic solution arranged as a zinc plate, the zinc plate act as anode. This anode loss of electrons from its valency cell, then form Zn plus 2 plus 2 electrons. These electrons move from anode to cathode. This anode is represented by negative charge and cathode is represented by positive charge. These anodic of cell and cathodic of cells connect with U shape of tube is called salt bridge. The salt bridge contains salt components of potassium chloride and potassium nitrate or potassium chloride and ammonium nitrate. These salt bridge to prevent mixing of solutions, to prevent accumulation of charge, to make electrical contact by the transfer of ions, balancing both sides. Sulfate ions move from cathodic of cell to anodic of cell. These cathodic of cells more than sulfate ions by the deposit of copper on cathode. Zinc plate to form Zn plus 2 to increases positive ions in anodic of cell. Those zinc ions balancing to transfer of sulfate ions from cathode to anode. This zinc plus Cu plus 2 gives Zn plus 2 plus Cu. Zinc plus Cu plus 2 gives rise Zn plus 2 plus Cu. Zinc plate arranged in ZnSO4 solution. This is anodic of cell. copper plate arranged in copper sulfate solution. This is act as cathode. This anode and cathode contact with U shape of tube is called salvage. Cell reaction generally write down Zn semicolon Zn plus 2 gives Zn changes to Zn plus 2 and concentration of solution 1 m Cu plus 2 1 m concentration semicolon Cu plus 2 copper sulfate solution concentration 1 molar concentration. These anodic and cathodic of cells contact with salt bridge. Salt bridge represented two vertical lines. These two vertical lines indication of salt bridge. Zinc semicolon Zn plus 2 zinc one vertical line. This single vertical line indication anode. Cu plus 2 single vertical line Cu. This vertical line indication of copper plate. Zn vertical line Zn plus 2 1m concentration Cu plus 2 1m single vertical line Cu. These two half cells connect with salt bridge. The salt bridge is represented by two vertical lines. These two vertical lines is called salt bridge. Electrolytic cell and galvanic cells are two different cells. These cells are using two different reactions. One is converted electrical energy into chemical energy is called electrolytic cell. It is converted chemical energy into electrical energy is called galvanic cell. This electrical cell, it is required source of electricity like battery. It is uses sources of electricity like battery. In galvanic cell, it is act as a source of electricity. It is produce electricity by the spontaneous redox reaction from anode to cathode. In electrolytic cell, cathode is represented by negative charge, anode is represented by positive charge. Cathode negative charge, anode positive charge. In galvanic cell, cathode positive charge, anode negative charge. In electrolytic cell, salt bridge is absent. In galvanic cell, salt bridge present. Two electrodes are present in same electrolyte. Two electrodes are present in different electrolytes. In electrolytic cell, using only one electrolyte are used. In galvanic cell, uses two different electrolytes. These two different electrolytes arranges two different electrodes. These two different electrodes, one is act as anode, another one is cathode. Electric current flow from anode to cathode. Electric current flow from cathode to anode in galvanic cell. This cell uses two different electrolytes. One is zinc sulfate, copper sulfate by passes of electrons from anode to cathode. These anode to cathode, how much quantity of electricity produced by measure using voltmeter. Anodic and cathodic of cells contact with salt bridge. It is continuous process of electrons. When removing of salt bridge, this process will be stopped. These are electrolytic cell and galvanic cell. Now we discuss about electrolytic cell and galvanic cell. In this class, we discuss the difference between electrolytic cell and galvanic cell, and what is a galvanic cell, what is electrolytic cell, what are the differences between electrolytic cell and galvanic cell, what is construction of galvanic cell, what is working process of galvanic cells, what is working process of galvanic cell, and what is cell reaction of galvanic cell. These are discussing today. Thank you once again.